Thank you for joining this session. I'm Milind Torney, and I'll be talking about automation today. Title for the presentation is Test Automation Can Be Waste of Time. I'm going to talk about few fundamental factors related to automation, and unless you are taking care of this factor, probably you are wasting time and resources. Everybody over here, I'm sure everybody over here understands importance of test automation, and that is the reason your team, your product is really investing into test automation. You are investing into test automation because you want to extract value out of it. If your test automation is really working, you are going to see these benefits. You will have good coverage, good trust on automation, faster runs, and minimal manual testing, and small regression cycle at the end of release. And you should be able to make rapid releases. Just think about it. Is this the case with you, or you are really facing some problems like these? So if your automation is not working, your automation is brittle. You have no trust in automation. There are a lot of failures. You need to fix those failures, and there is a lot of manual testing going on, and a big regression cycle at the end of release, and all these costs. So, in case if you are seeing these problems, you are facing these problems, that means your automation project is not working. And unfortunately, many teams in Semantic are struggling with automation projects. My team is also struggling with the automation project. Reason I came up with this presentation where I'm going to talk about 5 important factors that can help to improve the situation. Okay, so let's start with the first factor that I have. More is not always good. Over here, I am talking in the context of end-to-end. Typically, when you start automation, start working on the automation project, uh, what you have is list of test cases, heap of test cases, manual test cases. You start converting those test cases into automated test cases. Initially you will see some results, better results, and you will, looking at the results, you will invest more and more, and at some point you will start these problems. Automation becomes slow, it is brittle, it start failing. You need to fix those issues, and overall development and automation development and product development slows down. Infrastructure costs skyrockets. All these problems are peculiar characteristics of end-to-end automation. In fact, I would say that if you're adding more end-to-end automation, you're adding into these problems. And the key thing that I want to highlight here is that end-to-end automation does not even provide you good coverage. I'd like to elaborate this point a bit in next couple of. Let's do a quick exercise. Let's say you have a product to release, a very simple product. There is just single component C1, and you want to release this product with 100% test coverage, 100% automation coverage. If this C1 component exhibits 10 behaviors, in that case, you would write those 10 test cases, convert those 10 test cases into automated test cases, and if those are running green, you can ship the product. Well enough. Now, in the next release, your product becomes more complicated and you have one more component to worry about. In that case, what you need to do is you need to consider these two components working together, and if both of these components exhibiting 10 behaviors each, and in worst case scenario, if you consider all the combination, the number of test cases become 10 into 10, 100, considering all the combinations. you would automate those 100 test cases and you will achieve 100% coverage, and when it is green you can ship the product. Now the product becomes more complicated, and over here I'm showing 7 components, and 7 components with 10 behaviors each, and if you do the math again you will realize that number of test cases has grown exponentially. So let's do the math. You can see that with just 7 components, the number of test cases required to test this component with 100% coverage is like 10 million. This is absolutely not sustainable model. This is not probably good approach to follow. You cannot really chase 10 million test cases. And in the reality, the product that we work on ship hundreds of components. They have a lot of behaviors. You even don't know those, and you need to test those components on various environments, operating systems, hardwares, and if you go and calculate number of test cases required theoretically, this could be more than billion. And practically, you have just a limited number of test cases in your repository. It could be thousands. And if you try to calculate the coverage for those 1,000 test cases, it will be like 1,000 divided by billion, and it is going to be fraction. It is not really good coverage at all. Even if you add or if you double the test cases, it is going to be like a fraction into 2. So you're not really getting good coverage here. So the point that I wanted to make here is that no matter how much you test, it's not going to help. Coverage is going to remain low from theoretical numbers perspective. Some people will say that we have better approaches, means we'll sort of figure out P1s and P2s, prioritize P1s and P2s. We will map those requirements and precisely come up with that list. Well, that is well said, done. It is not easy to come up with those 1,000 or 2,000 test cases out of billion test cases. It's not going to be a scientific way, and ultimately you are sort of gambling. Do you really want to gamble, or do you need a really better approach for this problem? So the point that I wanted to make is that if you add end-to-end automation, it is not really helping you. You are adding into your problems, and probably it is not even adding the sufficient coverage. It is not even providing you sufficient coverage. So you have to consider this situation. I want to talk is about the exponential growth of task cases. We just saw with the approach of testing end-to-end, theoretically you require a lot of test cases, and it causes exponential growth of test cases. And if you have studied computer science, you will know that any solution that is with the exponential complexity is not considered as a good solution. It is hard on the computers. And normal approach to solve such problems is simplification. So let's try to apply some simplification. Can we do something like this, where we have these 3 components? Can we test these components in isolation? So we have C1, C2, C3. Each component can be tested in isolation. And if you test these components in isolation, in that case, you will require less number of test cases, like 10 plus 10 plus 10. It's not a multiplication, it's just the addition. So you are in a way solving the problem. So this is called as modular testing, which is very important to address the issue of exponential growth of test cases. Yes, you would say that this is not sufficient. Absolutely, this is true. It is not, and you will require something like testing for interaction. You need to test these components. These components are not really going to work in isolation. You need to test for component interaction. So over here, I'm showing that C1, C2, C3 are tested for component interaction. First, they are tested for tested in isolation, then for component interaction, and you are done. So, solution for exponential growth of test cases is modular testing plus integration testing. Let's think about a car. So this car consists of assembled out of thousands of components. Let's imagine how they must be testing the car. Do they test this car after everything is assembled, or they test each and every component and tested components are assembled and few tests are run on the final product? Answer could be obvious: modular testing and integration testing to go. So in the second point, I just talked about importance of modular testing, importance of integration testing in the testing strategy. Third thing, we can talk about pyramid structure. I'm sure some of you must be aware of this structure. This is famous software testing pyramid. This concept was developed by Mike Cohn in 2006 or 7 and published this concept in the book called as Succeeding with Agile. And since then, this concept was well accepted by all the experts, and many companies are following this concept successfully. So what essentially this pyramid means is that you need to do minimal amount of testing at the top of pyramid, and you need to carry out a lot of testing in the bottom. So on the top, you can see that manual testing and end-to-end automation. You need to reduce the amount of manual testing required and end-to-end testing required and push all the testing down towards the bottom of the pyramid, and bottom consists of unit test and component test. Unit test is class level testing done by developers. Over there you can expect 100% coverage, rather demand 100% coverage, and then the layer above is component testing, where components are tested in isolation. It is not duplication, it is like a complementing test done at the unit testing level, and above that multiple components can be tested for integration, and whatever that is not covered in the layers below should be tested in end-to-end testing, test automation. So this is the way the pyramid works. The key thing that you need to understand is that more the number of tests you push down, it is better, because unit tests and component tests are robust. They run pretty quickly. So just for example, in just couple of minutes you can run few thousand test cases, and comparatively on the manual testing side or end-to-end testing side, it requires something in minutes. So there is a huge difference. Then one more thing that needs to be noted is that development of unit and component test is relatively cheaper, and it provides good coverage, better coverage. You can deal with the exponential growth of test cases with the unit test and component testing, and with that coverage you can probably uncover the defects much earlier. If something fails with those test cases, you exactly know which component failed, which unit test failed, and you can fix those. So this is highly recommended. This pyramid concept is highly recommended for the testing strategy and automation strategy. Let's see what we have, what you might be having. You might have this structure where there are a lot of manual tests, a lot of end-to-end tests, and few unit tests and component testing. So this is not really a good pattern. This is like a completely anti-pattern. This is inverted pyramid. This is sad story. Uh, Probably you might have even worse case where you don't even have anything in unit and component testing level. So in this point, I wanted to recommend software testing pyramid strongly for uh, testing strategy and automation strategy. Okay, now we can talk about the next point that I have, flawed ownership model. Again, I'm going back to the pyramid structure. One thing I would like to highlight here is that every layer in the pyramid, like unit test, component test, integration test, leverages testing done uh, at the layer below. It complements the testing done in the layer below. It does not duplicate the testing. That is so key to be very effective. And the key thing is that if you want to work effectively, Dev and QA needs to work very closely. There should be really good interaction. That is the key factor here. Let's look at the uh, ownership model that we have. Of course, feature development, unit testing, component testing is owned by dev team, and probably end-to-end automation and manual testing is owned by QA team plus automation team. And there is gap between these two teams. They do interact, but not sufficiently. So what this causes is a lot of duplication, lot of inefficiencies. Developer does some unit test or components test, and QA does not even consider those, and they write their own test plan and do their own testing. They completely discount the work done by developers, and this is completely wastage again. And other thing that I wanted to point out is that few things or a lot of things that can be tested very easily, very cheaply in the layer below at unit test level or component test level are tested at higher level, at manual testing layer or end-to-end testing layer. That is highly inefficient. Third problem with the ownership model is that automation become afterthought. Generally, developers are not aware of what is being automated, and QA continues with the automation. They build something, and developers has not provided required testability features, and they build something which is brittle. They take long time, and it is highly inefficient model. So the point that I want to highlight is that if we want to be doing effective work, if you want to do effective work, efficient work with respect to automation, ownership model needs to be fixed. Probably it needs to be fixed. Along with that, organization structure may also needs to be fixed. So this is the pragmatic way or pragmatic approach that I would like to suggest. QA and development jointly own the responsibility. Only QA is not responsible for quality. Developer also own the quality. Dev and QA should brainstorm together, they work together, and they come up with approaches. They decide on what needs to be tested as per the pyramid, at what layer, what kind of test they will require, what mix of tests. When I say kind means unit test, component test, integration test, who is going to do those, and everything means they come up with the strategy, taking pyramid as a guidance, and they set their own goals. Once they set their own goals, developers know what testability features are required. They will build those features along with the product development. QA and development work in parallel and build automation. And during the feature complete, during the done, all the automation is complete, running green. So this is the approach that I would like to suggest. This is not going to be easy. It will require a lot of changes. Some level of mindset changes are required, but it is possible. A lot of companies are following this model. Specifically, Google is following this model. Okay, so next point that I have is about numbers. Numbers can fool you. Here I'm talking about numbers related to automation, numbers related to how automation is measured. It is famously said by Peter Drucker that if you can't measure it accurately, you cannot improve it. It is so true for automation. Just take one simple example. If you ask level of automation in for your product, then you will probably come up with answer like we have 20% coverage, 50% coverage, like that. But what exactly is that number? Is it really useful? This number is nothing but number of test cases automated versus number of test cases that you have. But this is not really a correct picture. It is completely misleading number. Why? Because let's say you have 10 test cases, and if you measure the code coverage for those 10 cases, let's say it is 50%. If you add 100 more test cases and if you measure the code coverage number, it could be again 50%. So you are adding those 100 test cases and there is absolutely no improvement in the code coverage. You are sort of covering the same paths. It is really not adding the value. So effectiveness of test automation can be measured with code coverage. This is really important. Next thing I would like to highlight is that measurement of automation can be done with help of manual efforts. You need to measure how much efforts you are put in, how much efforts includes provisioning the automation, setting up the automation, starting the runs, completing those runs, running, figuring out the results, fixing the automation. All those manual efforts that you put in the automation needs to be measured, and once you measure, you can improve those. I don't want to suggest specific metrics for measuring the success of automation. You can figure out what works for you, but my intention was to highlight key problems like how to measure effectiveness of automation and efficiency of the automation. Unless you measure these things really efficiently or really accurately, you cannot really improve your automation. So that was the last point that I had, and in the session today I covered 5 key factors. First one was about end-to-end automation. If you are blindly adding end-to-end automation, that's not going to work. Second thing that I talked about, how to deal with exponential growth. Modular testing and integration testing can be considered in your testing strategy and automation strategy. And third thing I have is about pyramid structure. That is something really important. Think about it. Fourth thing I talked about ownership model. Unless you fix the ownership model, you are not going to see a lot of improvements. And the fifth thing is, unless you measure, you cannot improve. So these 5 points are super important. Unless you address these points, you can't really build really effective and efficient automation, test automation. Probably you are wasting your time. That's all I wanted to cover in the session today.
Thank you for listening to me. Here are some references. Thank you. Thank you again.